When we look at Lean, we have to understand that Lean and Six Sigma, even though they marry very well together, they are two different methodologies because we're looking at effectiveness versus efficiency. In a Lean project, you may not necessarily be creating defects. You just might be not delivering the product on time to the customer. With Six Sigma, you're just not delivering the product within the customer specifications or their requirements. So you're basically creating an error. So in a Lean project, you may not have to deal with Six Sigma, but within Six Sigma, you will always have to deal with Lean. And with Lean, it begins by really defining the value of what you're solving for. I think we do a really good job of thinking that we know what we solve for because we always look at symptoms. But with Lean and with Six Sigma, we're able to isolate the actual root cause of our problem or our significance of that problem and be able to solve it effectively. So it begins by defining the value. Once we define the value, we have to map out the process. And mapping out the process in Lean, we talk about something called a value stream. And with the value stream, we're not looking necessarily at process after process after process and creating a flow chart or a process map. We're looking at how the process steps that we have within our process actually delivers value back to our customer. Because anytime we go to the store, anytime we as customers want to purchase something, we don't want to purchase something that doesn't bring value back to us. The next thing that we do is we create flow. And we do that by removing impediments that is stopping that flow from reaching or that value to reach to our customer. So such things as roadblocks or bottlenecks or things like that. And then we move to establish pull. And pull is just really fancy talk for us to be able to have the material or have the customer or have the service or whatever it is that we're looking for totally available when we want it versus having all of the stuff rushing towards us. And then finally, it's always about a pursuit to perfection. It kind of goes back to the whole idea of continuous improvement. Things are never perfect, and we can't remove all the variation out of a system, and we can't make that system perfect. But every single day, when we look at what is causing the problem, we can actually pursue that perfection. So every company needs to understand what value the customer places upon their products and services. So then what about Six Sigma? Well, Six Sigma, we've already kind of talked about the fact that it's about reducing variation. It's about making your process more effective by eliminating defects or errors. So Six Sigma is a highly disciplined, industry-neutral approach that can be used in several sectors, including IT, manufacturing, healthcare, defense, telecom, and banking and finance. And like I said, it focuses on developing processes, eliminating defects, and ultimately delivering quality products and services consistently. Being a consultant, I was able to work in a lot of these particular sectors, and a lot of times when we look at a process, they're the same, regardless if we're making something on an assembly line, whether we're transferring data from one point to another, whether we're dealing with patient access or patient flow in a hospital, or maybe it's navigating a website, or working in the banking industry in terms of being able to deliver quality products to our customers effectively. Six Sigma works within an acronym called də-MAY-ick. də-MAY-ick begins by defining the problem and your desired outcome. And it's also about defining what the real problem is. It's about understanding the data so that we can not only define the problem that we're trying to solve for, but also to create a dream state of what that desired outcome should really look like. Then we move into measure, where we have the ability to measure the current process to see exactly how it's performing. And then we'll analyze those steps. We'll analyze the data and identify the root cause of the variation. By applying statistical methods to our problem, we're able to isolate what the true root cause is. A lot of times, especially in business or even in our personal lives, we spend a lot of time focusing on symptoms, and we try to solve for that, realizing that the problem just never goes away. By using də-MAY-ick, we're able to actually figure out which one is our most critical X, which is the one that is causing not only our customer, but maybe our employees or maybe whoever, the most particular pain that we can solve for. After analyze, we move into improve. This is where we modify the process into our future state. This is what we want it to look like. And then after that, we go into control, where we sustain the process. And then just like in Lean, it's a continuous improvement. So once we've solved for that X, then we'll go solve for another one. And then we continue to make our process more effective. So with Six Sigma, like I said, it's all about reducing variation. And variation is evil. It is the enemy. We want to remove absolutely as much of it out of our processes or our systems as possible. So a Six Sigma process has 99.99966% defect-free rate, which means that's equivalent to 3.4 defects per million opportunities to create a defect. A lot of times when we ask you what is good enough, a lot of people will say that 99% is good enough. After all, it's only 1% less than perfect. A 99% when we were in school is still an A. But what's the difference between 99%, which is 3.8 defects per million opportunities, to 3.4 Six Sigma defects per opportunity? Well, let's run through some examples. To be 99% good with the Postal Service, that would equal 20,000 lost pieces of mail per hour. Now that's okay if we're dealing with junk mail or magazines that we don't care about or advertisements. But what happens if it's a check or a card or something important that you particularly need? 20,000 lost pieces of mail per hour is a huge amount of defects. What about 15 minutes of unsafe drinking water per day? Now, it's not 15 straight minutes of unsafe drinking water. It's randomized 15 minutes throughout the day. Would you be willing to take that opportunity, that chance to possibly have unsafe drinking water? How about 5,000 incorrect surgeries performed every week? That's a huge amount of surgeries, but yet it's 99% good. Or 2 commercial airplane accidents every single day. And you won't know what airport, you won't know what flight, you won't know anything about it. You just run the chance. When we apply də-MAY-ick to these exact problems, we're able to see the variation be reduced significantly. So when we're looking at the 20,000 lost pieces of mail per hour, the difference is now just 7 lost pieces of mail per hour. In terms of the 15 minutes of unsafe drinking water, that now goes to 1 minute of unsafe drinking water every 7 months. 5,000 incorrect surgeries per week drops to 1.7 per week. And then finally, the 2 commercial airplane accidents per day drops to just 1 accident every 5 years. So when we say that something is 99% good, we're looking at all the effects of it on the left. And by applying process improvement methodologies such as Lean and Six Sigma, we're able to decrease that variation and show significant results. And these are just some examples from multiple areas that affect our lives. Think about what we could do with your particular process in your particular organization or in your home.